Welcome everyone to this explainer. I'm absolutely thrilled to have you here today because we're going to look at the world just a little bit differently. We often think of complex systems engineering as this highly abstract, deeply mathematical field, right? Reserved for specialists in white lab coats or folks sitting in dark control rooms. But what if I told you that some of the most profound concepts in systems thinking are actually hiding right in plain sight? They're literally baked into the common everyday sayings that we've all grown up hearing.
Think about this classic saying for a second. A stitch in time saves 9. I mean, you've probably heard your parents or grandparents say this at some point. It sounds like simple, folksy wisdom about mending a torn jacket. But this humble little phrase, it's actually our first major clue into how complex systems behave over time.
Okay, let's dive into this. What could these simple, traditional sayings possibly have to do with the rigorous discipline of systems engineering? Well, in this explainer, we're going to use these everyday phrases as a sort of gateway to demystify systems thinking. We're definitely not looking to replace your formal linear analysis or specialized engineering skills. Instead, we're adding a totally new, really powerful lens to your toolkit. It's a way to recognize hidden patterns and relationships that, frankly, standard linear analysis might completely miss.
So, here's our agenda for today. We're going to cover 1. Hidden systems wisdom, 2. A stitch in time, 3. The final straw, 4. Playing whack-a-mole, and finally, 5. Noticing patterns over time. Let's get right into it.
Section 1. Hidden Systems Wisdom. Let's get our foundational concepts down.
Systems thinking. When you get right down to it, it's really just a way of noticing relationships, boundaries, feedback, context, perspectives, and how things change over time. It's super crucial to understand that this is a complementary tool to your standard linear analysis. While linear analysis breaks things down into individual parts, systems thinking zooms out to see how all those parts actually interact with each other. It's meant to help newcomers and seasoned experts alike spot those broad behavioral patterns that are, honestly, incredibly easy to overlook when you're buried deep in the details. And one of those core interactions is feedback. This happens when the effects of an action return to influence future action. Definitely keep this in mind, because ignoring these feedback loops, or just not realizing they're even happening, is almost always where massive system breakdowns begin.
Section 2. A stitch in time. Let's talk about early intervention.
Now, what's really interesting here is the deeper lesson behind a stitch in time saves 9. It's simple, but it's profound. A small tear in a coat is super easy to repair right now. But if you ignore it, it spreads, requiring drastically more effort later on. The system lesson we're looking at here is entirely about early intervention and managing a very specific, actually quite dangerous system dynamic.
And that dynamic is delay. In systems thinking, a delay is simply the gap between an action and its visible consequence. It's kind of the silent killer of projects and professional relationships alike. Why? Because when consequences are delayed, we falsely assume that our inaction isn't causing any harm. We think we're fine right up until the moment we're not.
Think about how this cascades in a real-world professional environment. Step 1. You have a small, unclear requirement or maybe a weak handover. It's just a tiny tear. Step 2. The feedback on that is delayed or just totally ignored because, well, everyone is swamped. Step 3. Suddenly, you are facing massive project rework and total scheduling disasters. That tiny tear in the code is exactly like a small integration issue in a major engineering project. The pattern is literally identical.
So the absolutely crucial point here is to ask yourself, what early signals are we missing right now? Where could a really small, inexpensive action today prevent a massive, highly complex problem down the line? Training yourself to look for those tiny tears is your first big step into systemic thinking.
Section 3. The final straw. What happens when stress slowly accumulates?
We all know this saying, the straw that broke the camel's back. We use it all the time to describe the exact moment everything falls apart. But the brilliant systems insight here is that systems rarely fail because of one massive, devastating blow. Instead, they fail due to accumulated, often totally invisible stress. The final trigger, it's almost never the deeper cause.
In formal systems terminology, we call this a threshold. A threshold is a specific tipping point where accumulated pressure leads to a sudden and often catastrophic change. Up until that threshold is crossed, the system might look totally fine. The camel is standing, doing its thing, until suddenly it just isn't.
And this brilliantly illustrates exactly what we're talking about. Imagine your team's baseline workload. Now add repeated scope changes quietly piling on pressure over several months. Then one tiny, seemingly harmless email comes in and the team completely burns out, crossing that red threshold of breakdown. Now, if you only look at that final email, you'd think, wow, what an overreaction. But systems thinking shows you the accumulated load building up over time.
I really want to challenge it with this question. Are we mistaking the final trigger for the deeper cause? In your own organization, when a breakdown happens, don't just blame the last straw. Take a step back. Look at the pressures that were accumulating long before the collapse ever happened.
Section 4. Playing Whack-A-Mole. Let's look at unintended consequences.
Whack-a-mole. Okay, it's a really fun arcade game, but it is a terrible management strategy. You hit one problem with your mallet, and bam, another one instantly pops up somewhere else on the board. This saying perfectly captures a fundamental reality of highly interconnected systems.
The actual scientific equivalent of the whack-a-mole game is unintended consequences. These are the ripple effects of an intervention that were not intended or even anticipated by the people trying to solve the initial problem. Because a system is completely interconnected, a change in one part is going to ripple right through the rest of the entire shebang.
You can really see the real-world impact of this. Let's say management adds tighter administrative controls to fix a very specific local error. They pat themselves on the back thinking they solved the problem, but look at the broader reality. Those new controls just created massive delays, forced employees to use risky workarounds, and actually shifted the whole burden onto an entirely different team or supplier. The problem wasn't solved at all. The mole just moved.
Whenever you implement a quick local fix, you absolutely have to ask this vital question. If we intervene here, what else might change? Are we actually solving the root problem, or are we literally just shifting the burden to a future date or shoving it onto another department?
Let's move to Section 5 and see how this all builds together, noticing patterns over time.
So, to summarize what we've covered today, delayed effects, accumulated pressure, recurring problems, shifted burdens, and unintended consequences. Look, these aren't formal math models, but they are absolutely vital starting points. They train your brain to notice behaviors that standard linear analysis will skip right past.
And when you start noticing these patterns, you gain something incredibly powerful, and that's leverage. Leverage is a place in a system where a small shift in one thing can produce massive changes in everything else. By understanding things like delays, thresholds, and feedback, you don't just react to problems anymore. You actually change the rules, the timing, and the underlying assumptions to fix the system itself. It's a total game changer.
If you want to keep building this toolkit, I highly recommend checking out the SEBook article titled Guidance for Getting Started with Systems Thinking. Remember, as a beginner, you definitely do not need to master every complex modeling method all at once. Just start simple. Start by recognizing the sayings. So, I want to leave you with this final, empowering question to ask yourself the very next time you face a stubborn challenge at work or even in life. What pattern is this situation showing? Is it a tear in a coat, a burdened camel, or maybe a game of whack-a-mole? Because once you name the pattern, you hold the power to change the system. Thanks so much for joining me on this explainer, and happy thinking!